I believe you have an empty page on page 734. Now, poker hands can be a little bit complicated to actually count. So we are going to look at counting certain poker hands and how to do it. The reason they're hard to count is you can easily overlap things if you're not careful. So, here's our first poker hand that we're going to count. How many poker hands have, let's just go with start with one pair. What a poker hand with one pair looks like, you could have 2 5s and then the other 3 numbers or letters or whatever cards have to be different. That's an example of a poker hand with one pair. How do we count a poker hand with one pair? Well, one of the things that we're going to do is look at the different groups that we have here. Can you see that we're going to have a pair? This will be one group of 2, and then there's 3 single cards. And in counting poker hands, you're going to count groups that are the same size at the same time with combinations. So when I go to pick my pair, there are 13 numbers that could be the pair, and I need to choose one of those numbers to be my pair. So I could choose 5s, I could choose 7s, I could choose aces. That 13 choose one just decides which number or which kind of card is going to be my pair. And since there's 13 different types of cards, it's 13 choose one. Once I choose 5s, for example, how many 5s are in the deck? There's 4. So now we have to make sure we choose which of the 2 of the 4 are we going to pick. So 13 choose 1 times 4 choose 2. This together is all possible pairs. For counting the rest of our numbers, we have 3 single cards to go. We have to choose those 3 single cards all together. Because if I chose ace, 7, king, it's not different than 7, king, ace. Okay? So we choose all 3 numbers at the same time. By choosing the 3 numbers with 12 choose 3, we have said the order doesn't matter. If I choose aces, 7s, kings, or kings, aces, 7s, or 7s, kings, aces, that all counts as the same. Once you've chosen your 3 cards, how many aces are in the deck? There's 4 of them. How many do we need to choose? We need to choose 1. How many 7s in the deck? There's 4 of them. We need to choose 1. How many kings in the deck? There's 4 of them, and we need to choose 1. This part here chooses 3 single cards.
Mr. JR?
Yes?
I am really confused as to what's happening right now.
These are going to be tough, and what's going to happen is after if we just try to explain one example, it's going to be really tough. Once we do a couple of them, we start to see some of the patterns in our counting. So to reiterate what we've done here is, first of all, we've decided what are the group sizes of our cards. We have a pair, which is 2 cards together, and 3 single cards. We have to count cards of the same size at the same time. So since I only have 1 pair, I choose 1 number of the 13 first, and then choose which 2 cards of the 4 are going to be that pair. So the 13 choose 1 picks what number you're going to have, 5s or 7s or 8s or kings or jacks. And since there's 13 different kinds, that's why it's 13 choose one. Once you've decided on which number you're going to have for your pair, then you say, well, there's 4 of those cards in the deck. There's 4 fives. There's 4 kings. Whatever you chose for your pair, there's 4 of those, and you just need 2 of them. But the king of clubs and the king of spades are different than the king of hearts and the king of diamonds. And so we do 4 choose 2. Again, we use choose because it doesn't matter. Club spades is not different than spades clubs. So we take the order out that way. After we've chosen our pair, we choose our 3 single cards. These can be chosen differently because there's going to be no overlap from this second group and this first group. We choose all 3 numbers at the same time because they're all the same size, like single cards. And then there's 4 of the one card that you pick, so you need to choose which one you have. 4 of the other card that you pick, so you need to choose which one. And 4 of the last card that you need to pick. What's that? It has to be 12 because you can't put a 5 in there because you've already chosen one number to be your pair. You can't choose 5s again here, otherwise you'll get 3 of a kind instead of a pair. What? So the first squiggly bracket part picks our pair, and the next squiggly bracket part picks our 3 separate cards. Okay, let's look at 2 pairs. An example of a hand with 2 pairs could be that you get 2 aces, 2 sevens, and a 5. Would it be better if I put like symbols with these, or are you okay with just ace, ace, 7, 7, 5? Okay, that's an example of 2 pairs. What are our sizes? As far as looking at our sizes go, we have those 2 are pairs. They'll need to be chosen together. And then we have a single card. So if we do our pairs first, we have 13 cards, and we need to choose which 2 numbers now are going to be our pairs. If you choose aces, how many aces are there? There's 4 aces, and you would need to choose which 2 aces you're going to use. If you look at sevens, there's 4 sevens. You need to choose which 2 you're going to use. This together will give us 2 pairs. Following the same way, if we're going to do our single card now, how many numbers are left? 11. So we could do 11 choose 1. And then if you chose the 5, how many 5s are there? There's 4 5s, and you need to choose 1. This will be a single card. Does it make sense that this one, if you wanted to do it all at once, you could have done 44 choose 1? Because after you've picked your 2 pairs, you have to take out all of the aces and sevens out of the deck then, and there would be 44 cards left. And then you just need to choose 1 more to get your single card. But again, if you want like 11 choose 1, that's 11. 4 choose 1, that's 4. 11 times 4 is 44. It works out to the same thing. We can't do 44 choose 2, or we can't do 48 choose 2 because we might get 2 different numbers. Three of a kind. An example of 3 of a kind. Ooh, I was going to use 6s. That would have been bad. Here we go. 2s. 2, 2, 2, 5, 8. So 3 of one kind, and then 2 numbers that are separate. Okay? The reason we don't have the last two the same is that's a different hand in poker. We'll count that one a little bit later. So a 3 of a kind hand has 3 of the same, and the other 2 are 2 separate cards that aren't the same number. Can you see, as far as grouping goes, you have 1 triplet and 2 single cards. Those will be counted at the same time. So if we start with our triplet, there's 13 numbers. You choose one of them. There's 4 of that kind. You choose 3 of them. This counts our 3 of a kind. How many numbers do we have left? We have 12 numbers left. We need to choose 2 of them. And then there's 4 fives, choose one of the fives. There's 4 eights, choose one of the eights. And that'll count 2 single cards. What would you do if you wanted a really bad hand? All 5 different. Okay? So we'd have like ace, 7, queen, 3, 2. Wonderful hand. Ace high. Well, if all 5 were different, you'd have to choose them. They're all same size, so you have to choose all 5 numbers at the same time. And then 4 choose 1, 4 choose, oh, this pen is wonderful today. 1, 4 choose 1, 4 choose 1, and 4 choose 1. So as I said a little bit earlier, when we just did our first example, things were a little bit hard to grasp. Now that we've seen a couple of them, are starting to see the pattern and make a little bit more sense of what we're doing. Four of a kind is relatively the same. Let's do full house. Oh, by the way, with the 5 different, with the 5 all different, that does count ones that are 2, 3, 4, 5, 6. It also counts the one that's 10 of hearts, jack of hearts, queen of hearts, king of hearts, ace of hearts. Because that would be all 5 different. That one's actually really good. That's a pretty good hand. That's like, yeah, that is the best hand. So when figuring out all 5 different, if you weren't going to include straights and flushes, you would have to subtract those out. And so that would be complicated to do. But for a full house is when you have 3 of one kind and 2 of the other. Ah, good choice of numbers. Well, they're both different sizes, so you could choose your 3 of a kind first. And then choose your 2 of a kind after. And so this gives you a little bit of sense of how you would calculate some poker hands. When you figure out how many combinations are of each of them and you actually write the numbers down, you realize why a full house is worth more than 2 of a kind. Because there's a lot less combinations out there to get that hand. And why 4 of a kind is higher than a full house. I think that the one that as far as thinking about it, most people realize, sort of like common sense, that getting 3 of a kind is more rare than getting 2 of a kind. Right? And getting 4 of a kind is more rare than getting 3 of a kind. But I always find that trying to remember, is it more rare to get 3 of a kind, or is it more rare to get 2 pairs? Now you can see, if you calculate these numbers, the 2 pairs and the 3 of a kind, how much more rare it is, how much of a better hand it is. How much better, perfectest. Okay.